Global study reveals a powerful hidden way trees are fighting climate change. Vincent Gucci from The Conversation reports tree barks in the world's forests absorb the greenhouse gas methane my colleagues and I have demonstrated for the first time on a global scale. A discovery that could have big implications for tackling climate change. So they absorb methane. As trees photosynthesize, their leaves take up carbon dioxide and CO2 and lock it away as biomass in their trunks and branches, providing a long-term store of carbon. But now our large-scale study proves that there's another way that trees absorb greenhouse gases, so forests can provide even more climate benefits than previously thought. Methane has contributed about a third of the observed climate warming since pre-industrial times. Concentrations of methane in the atmosphere have been rising rapidly for the best part of 2 decades. That's a real problem for Earth's climate because methane traps much more heat in the atmosphere than the equivalent amount of CO2. But while CO2 can last in the atmosphere for hundreds of years, methane has a lifetime of around 10 years. This short atmospheric lifetime means that any changes to sources of methane or processes that remove methane from the atmosphere, known as methane sinks, can have rapid effects. If removal is enhanced, this can be a quick climate win, helping to mitigate escalating climate change. And that's why researchers are so interested in understanding how methane gets into the atmosphere and how different processes remove it. It's why my team of ecologists and climate scientists have been studying the exchange of methane between tree bark, a surface that had previously been overlooked for its climate contribution, and the atmosphere. Wetlands are known to be the primary natural source of methane. Trees in swamps and floodplains can emit methane from the lower portions of their trunk, but methane exchange in trees growing on free drained soils that don't flood, that includes most of the world's forests, of course, has not been well studied until now. We measured methane exchange on hundreds of tree stumps in forests along a climate gradient spanning the Amazon and Panama through to Sweden and forests near Oxford in the UK. We used a simple plastic chamber that wrapped around the tree trunk, which was then connected to a laser-based methane analyzer. At first, we looked for methane emissions from trees, and some do emit a small amount from their trunk base, but the surprise happened when we measured higher up the trunks. Trees were taking up methane from the atmosphere, and this methane removal grew stronger the higher we went up, with methane removal from the atmosphere dominating overall exchange. And next, we investigated whether this was a globally important process. To do this, we needed to calculate the global area of the tree bark. Using a technique called terrestrial laser scanning, we mapped tree woody surfaces down to the finest twig. And we discovered if the bark from all the wood's trees were laid flat, it would cover all of the Earth's land surface. Potentially, this represents a vast area for gas exchange between tree bark and the atmosphere, but this mechanism is still poorly understood. An untapped sink. In total, our cautious first estimate is that trees take up about 25 and 50 million tons of atmospheric methane each year, with most taken up by tropical forests. This is similar to the only other land-based methane sink, which is soils, and it makes temperate and tropical trees 7 to 12% better for climate than they are currently credited for. But unlike soil, which is not changing in area, forests are contracting and expanding through deforestation and reforestation. These changes can influence atmospheric methane. If we reforest and plant trees in the right place, more methane could be drawn down from the atmosphere. Clearly, decarbonization of the global economy and energy system is the key way to address climate change, but this capacity for tree bark to absorb methane offers another angle of attack as a nature-based climate solution. There may be new ways to improve methane uptake in plantation forestry by selecting trees that are particularly good at atmospheric methane removal or modifying tree bark microbial communities. Nations could be given better incentives to preserve existing natural forests and avoid further deforestation. Expensive reforestation projects may become more economically viable under reputable carbon offset schemes that consider methane. This new evidence reinforces the importance of trees and forests for our climate system, while demonstrating there is still much to learn about these valuable ecosystems. This is from the conversation here on the Creative Commons by Vincent Gauci, Professional Fellow, School of Geography, Earth and Environmental Sciences, University of Birmingham, on Science Alert. Please leave your comments and thank you for your support. Finally, support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.